Hello everyone, welcome to the course on control system. Myself Ravichandran, I am here to present a subject called control system. Today we will begin with an introduction to control system, which is a fundamental aspect of electrical and electronics engineering. This subject is essential for understanding how different systems can be managed, directed or regulated to achieve desired outcomes. So, in Model 1, we will cover the basics of systems and control system. We will look into the definition of system, explore various types of systems, and dive into control system, their advantages and disadvantages, and their practical applications. So, by the end of this model, you should have a clear understanding of why control systems are crucial in engineering and their various real-world applications. Let us begin by defining what a system is. A system is a collection of components that work together to achieve a specific objective. So, in another way, a group of components, a group of elements are connected together to perform a specific function. So, that we call it as systems. So, for examples, include physical system like mechanical or electrical system, biological system like the human body and ecosystem, and economic systems like market structures and financial systems. At the end, an automobile is an excellent example as it combines mechanical, electrical, and control system to function efficiently. Next, we are move on to the types of systems. There are various types of systems we can categorize based on their characteristics. So these include linear and nonlinear systems, static and dynamic system, time invariant and time variant system, and causal and non-causal system. Understanding these types help us analyze and design control system effectively. First, we are going to see the first type of system, a linear and nonlinear system. A linear system is one where the output is directly proportional to the input, satisfying the principle of superposition. That system we call it as a linear system. In another way, the output of the system varies linearly with the input. So that also we call it as a linear system. So it's the system satisfy the principle of superposition, which means if the system it is satisfy the additivity and homogeneity, that system also we call it as linear system. So for example, in Ohm's law, we already know the Ohm's law, that is V equal to IR. So which means the voltage across a resistor is directly proportional to the current through it. So make it a linear system. This proportionality allows for simpler analysis and predictability of the system behavior. So that is why we are telling this is as a wonderful example for a linear system. In contrast, a nonlinear system does not have direct proportionality between input and output. An example of this, the motion of pendulum or the behavior of diode. In this case, the relationship between input and output is more complex, often involving exponential or other nonlinear function. And moreover, this nonlinear system it does not satisfy the superposition principle. So that is also one of the definition for a nonlinear system. So next we are move on to the static versus dynamic system. In static systems, the output depends only on the current input or present input with no memory of past inputs. For example, a resistor in an electrical circuit is a static system because the voltage drop across it any instance depends only on the current through it at the same instant. So that is why the static system, the resistor is the best example for the static system. In contrast, the dynamic system, however, have memory and their output depends on both present and past inputs. Capacitor and inductors are examples of dynamic system. In capacitor, the voltage depends on the integral of the current over time, meaning it has memory of past currents. Similarly, in an inductor, the voltage depends on the rate of change of current, uh, which also incorporate past current values. So that is why the capacitor and reactors are taken for the best example for dynamic systems. The next important system is time invariant and time variant system. This is one of the important systems. Time invariant systems have properties that do not change over time. The output is independent of when the input is applied. For example, electrical circuits with the constant components like a resistor, capacitors, and inductors with the fixed values are time invariant because their behavior does not change over time. So that is why we are take it this electrical constant components are the best example for a time invariant system. So in the next slide, the time variant system, however, have properties that change over time. The output varies depending on when the input is applied. An example, this is a seasonal climate model where the behavior of the system changes with the seasons or time of the year. So next we are move on to the causal versus non-causal system. A causal system's output depends on present and past inputs. For example, a thermostat controlling an AC motor only uses current and past temperature measurements to the control system. And the next side, we have a non-causal system. Non-causal system anticipate future input based on past data. Uh, an example is a weather forecasting system which predicts future weather conditions based on past and present data. Similarly, missile guidance system, that is also one of the best example. So in this system also the future position and the trajectories based on current and historical data. So that is why these are all the taken for the non-causal system. So next, the main important thing is, directly we are dive into the control system. So the first we are going to see the definition of control system. So the definition of the control system is a group of components or group of elements are connected together to perform a specific function in which the output is controlled by input. So that is the definition of a control system. In another way, it is regulate the behavior or other devices or systems to achieve desired result. This fundamental concept is applied in various domains from household appliance to industrial automation. In the next slide, we are going to see the types of control system. There are two main types of control system. The first one is open loop control system, and second one is a closed loop control system. Open loop systems do not use feedback to determine if the desired output is achieved, whereas the closed loop systems use feedback to adjust and achieve the desired result. So first, let's take a look on open loop control system. An open loop control system is one in which the control action is independent of the desired output. For example, a washing machine. A washing machine set to run for a specific time without sensing the cleanliness of the clothes operate on an open loop principle. It does not adjust it operations based on the actual cleanliness of the clothes. Hence, no feedback is used. So that is why the washing machine is the best example for that open loop control system. And next, we are move on to the advantages and disadvantages of open loop, closed loop, open loop control system. Open loop systems are simple, economical, easy to construct, and generally stable. However, they are often inaccurate and unreliable because they do not automatically correct the deviation in the output due to the disturbance. This makes them less effective in applications where precision is critical. System. The next part, the closed loop control system. A closed loop control system is one where the control action depends on the desired output. It uses feedback. So the main difference between open loop and closed loop control system is the feedback. So it uses feedback from the output to compare the actual output with the desired output and adjust it accordingly. An example is a thermostat controlling room temperature, which is continuously senses the temperature and adjusts the heating or cooling to maintain the set temperature. So the thermostat is the best example for that. So this is a block diagram of closed loop control system. So here we have a lot of elements present in the closed loop control system. The first one is input, controller, plant, output, and feedback elements. The finally error detector. So this is the overall block diagram representation of the closed loop control system. Because I have already mentioned that thermostat is the best example for closed loop system. Because this feedback is the plays a main role in this closed loop control system. Based on that only we are achieving the desired output that is equal to the actual output. So next we are move on to the advantages and the disadvantages of closed loop control system. Closed loop systems are accurate, less affected by noise, and can be made more stable by reducing sensitivity. However, they are more complex and costly, can lead to oscillatory response due to feedback, and require more careful design to ensure stability. Dissipate these challenges, their ability to maintain desired output preciously make them invaluable in many applications. It is the best example for closed loop control system. Here I am consider air conditioning maintaining desired temperature. This is actually look like the block diagram of closed loop control system. Here I am considering the plant is room, control system is a air conditioner, reference is desired temperature, control input is a compressor on and off, output is output temperature, disturbance factor affecting ambient temperature, feedback measure temperature. So this is actually look like a block diagram of a closed loop control system. Let's compare open loop and closed loop control system. Open loop systems are simpler and less costly, but less accurate and reliable. Closed loop systems, while more complex and expensive, provide higher accuracy and stability by continuously adjusting based on feedback. The next, the main purpose of studying control system. The studying control systems enable us to understand and predict systems behavior, design efficient and reliable systems, enhance automation, improve system stability, optimize performance, troubleshoot issues, innovative new technologies, and finally apply this principle to real world problems. So this is why we are studying the control system subjects. The next we are move on to the main part, the learning outcomes. By the end of the course, you will be able to identify and describe basic concepts of control systems, classify different types of systems, model systems mathematically, analyze system behavior, design and evaluate control system, implement control strategies, and troubleshoot and optimize the system effectively. So these are the learning outcomes, and parallelly I mentioned the cognitive level of each outcomes. So in the conclusion, we are coming to an end. So, in the conclusion, understanding control system is vital for developing efficient and reliable system across different engineering disciplines. Mastery of this concept will equip you with the skills needed to innovate and solve complex engineering problems. So that is my conclusion of this today's session. And thank you for your attention. Now I would like to open the floor for any questions you might have regarding today's lessons. Feel free to ask for any clarification or additional information on the topics we have covered. Or in case if you have any doubt, you have to please post it in the comment box. I will reply as quick as possible. Thank you so much, guys.